Hi guys, this is PT21 Game 2. It's a bit of an unusual game. I don't think you'd see anything quite like this on a modern LSAT, and it's from one of the unpublished prep tests, so maybe games like this are the reason why those stayed unpublished, but still, they're great practice for bashing through some logic, even if they're a bit unusual. And this particular game seems to share a lot of features in common with grouping games, but there's enough of an ordering element to it that we're looking at it in that context. It's also unusual because we get 3 conditional rules, and like I said, you'd normally see something like that on a grouping game. Here, they're used for ordering, and they are essentially the type of conditional rules that you do see on ordering games. So for the game, we have just 3 spots, 1, 2, 3, and then 9 pieces that can go in there. So it's an unbalanced game. We're not going to use 6 of these pieces. So any order is going to just be filling up these spots. And then that's it. Nothing stacked up on top or anything. That'd be a no-go. So for the first rule, we see that whenever 1 is purple, then light 2 has to be yellow. So 2 yellow. And note it wouldn't really matter if you did this as like P and 1, then yellow and 2. That's up to you. But for me, in my brain, it makes the most sense to do 1 purple as saying that the purple's in 1. When we just get conditional rules, naturally we're going to want to see the contrapositives too. And here's this contrapositive. This would be 2 not yellow, then 1 not purple. It might be useful for doing the game to note that what does 2 not yellow mean? Well, it would mean also that 2 is purple or green, then 1 has to be yellow or green. So I think it might help you down the road to write that out. Yellow, green. And it might be worth noting that these are exactly the same rule. So put something in saying that these are exactly the same rule, reminding yourself of that. For the next rule, we get whenever 2 is green, then light 1 has to be green as well. 2G, then 1G. And then for our contrapositive, not 1G, then not 2G. And then if we want to interpret this the way we did here and write it in positive terms, we'd have 1Y or P, then 2Y or P. Okay, one more rule to deal with, and this one is if light 3 is purple or yellow, then light 2 must be purple. Light 2 is purple. Then we'll do the same process here. Not 2P, then 3, not 3P or Y. And then that's going to be written in a positive way as 2Y or G, then 3 has to be green. Let me make sure that's a capital G. Now, the last thing we want to do here is see where we can link some of these rules up. And I think it gets way easier because we wrote them out in positive form with these contrapositives. Rather than leaving the cross mark, we switched it into what that means. Well, look up here, 1P then 2Y. Well, if 2 is Y or G, then 3 has to be G, right? So we can just put a little mark then saying, we know this means 3 is G right here. Right? What about this rule? Here we see 3 purple or yellow. If 3 is purple or yellow, then 2 is purple. Well, if 2 is purple or green, then 1 is Y or G, right? So we could do that 1, Y or G. It's worth noting there's nothing that can link up with this second rule. That sort of stands on its own. Okay, and with that, we're ready to move on to the questions. For 7, even though this looks tricky to work with, we just do this like any other acceptability question. You take your rules one at a time and see if they're violated anywhere. So I've listed out all our possible orders that the question gives us, and we got to find the acceptable one. Let's take this rule first. If 1's purple, we got to see 2 yellow and 3 G. So 1 purple, nope, that's gone right there. 1 purple, that's gone right there. Cross them off. Nothing else that rule applies to. Well, it would apply to D, but it looks acceptable. Here we see 2G, we got to see 1G as well. Oh, that's good up here, so that rule doesn't help us there. What about the last rule? If 3 is purple or yellow, then 2 has to be P. So that's gone right there, and that's gone right there. And that leaves us D as the correct answer. 8 asks us what happens if light 1 is yellow. So we put the yellow in the 1 spot, and then it's saying any of the following can be true except, so we gotta find one that can't be true. And my eye just jumped straight to this 2G here. Well, if 2 is G, then 1 has to be G as well. And with 1 is yellow, that can't be possible. So this is something that can't be true right here. If you wanted to, you could make some inferences using our rules. Well, if we know 1 is yellow, then 2 is either yellow or purple, right? And that's about as far as we can get. So I would have just gone and used these and immediately seen this can't be true, right? If 2 is yellow or purple, it can't be G. So A is gone, and that's our right answer. With 9, we have a good shortcut because it's saying there's exactly one possible color sequence of the lights if which of the following is true. Well, if you did your work properly up front and made the inferences that you can make, you'd already have seen that we had this chain here, right? Where if 1's P, then we know exactly what's going on in the whole order. So I'm looking for an answer right away that says 1 is purple, which then triggers this whole chain, and then you can infer via modus ponens that 2's yellow and 3's green. We know the whole chain. And then right away you see that's our answer, A, L is purple. 10 says if no green bulbs are selected, how many possible color combinations are there? How many different color sequences of the 3 lights are there? So the place I wanted to start was back here because we had that rule about what happens if we're not green. Purple or yellow back here, and then that makes sure that 2 is purple, right? And then 1 has to be yellow or green in that case because that rule we got from combining this rule with this rule, right? So then this is yellow or green, but green's not possible. So now there's only 2 combinations possible, YPP and YPY. Sorry, YPY. 2, and that gives us an answer choice B as the correct answer. 11 is clearly the kind of question that is trying to make you look at each one of these, so it might be time-consuming if you try to think about the problem too much before just diving into trial and error, right? So you got to evaluate all of these one at a time. And it's saying, if all the lights are a different color, which of the following could be true? So the first thing we see is that light 1 is green, and then light 2 is purple. And I'm just trying to figure out if this could be okay with this one being yellow. I make the last one yellow. Look at what rule comes into play. If 3's yellow, then 2 has to be purple. Yeah, that checks out. And then, is there any reason why 1 can't be green? No. 1 being green doesn't trigger any of these rules, right? You look at it, so everything's okay, and that gives us A as the correct answer. No reason to even look at the rest of them. Okay, so that game was a pretty quick solve, not too tricky. Some things to keep in mind is that we were way better off with the contrapositives written out in a positive way rather than in this negative way. And that's only possible when not green, for example, has a distinct meaning. So I write not green, not yellow up here, for example, and that translates to either P or G. So it's a useful advanced skill that might come up rarely to be able to turn a contrapositive back into a more positive way of expressing it. And then the other thing to note is that we had to see where the rules could combine. Otherwise, we were going to have a lot of trouble solving the game. So if you saw that, you were in pretty good shape. All right, catch you on the next game.